Hello, I'm Andrew Smith from the Open University Cisco Academy team, and I am now covering Module 15, the application layer, as part of the CCNA Introduction to Networks. And as you can see, I'm going to be doing a little demonstration in a little while. Obviously, with the application layer, we've got a range of different application presentation and session layer services on OSI. We've got peer-to-peer, we've got a range of protocol addressing services and file sharing services. I'm going to be whistling through them reasonably quickly. Now, obviously, the OSI model, we've talked about the fact that it's legacy. We've talked about the fact TCP/IP model covers all of that. And presentation and session, where you've got the session, the socket, the stream. And then you've got the presentation, the media type, and then you've got the application, the thing that communicates, which kind of does encapsulate all of it. And I can see why the TCP/IP model just pretty much bags them all together quite comfortably. Obviously, we do need to consider the formatting of data. We do need to consider what kind of data is being transmitted, but then the protocol, the application, and the technology will actually handle that. So obviously a JPEG is an image and will be handled whether it's on a web page or within a Word document. A movie could be handled on a web page or via a streaming service. So you can see where the TCP/IP model sort of brings together that which is separated in the OSI model. But what's quite important is you've got different protocols and they operate very much at sort of different layers of the OSI model. DNS is obviously an application that is transported by the transport layer, but then DNS will offer a service on a server. Now, on the right hand side, I have deliberately set up 3 different servers. You will learn that you can actually set up all of these servers and services on one server on Packet Tracer, but I've separated them for practical reasons, and I'll demonstrate them in a little while so you can actually see what happens. I'll start off with the web, then set up the DNS and so on. So we still talk about peer-to-peer connections on a local network. Obviously peer-to-peer, I want to talk to my internet-enabled printer and send something to it. That will be a peer-based communications, but it will be found on my network accordingly. And there are other peer-to-peer applications that use an index server to actually enable or act as an intermediary for point-to-point communications. And we have web file sharing services like BitTorrent amongst others, but there is still authoritative databases, but the database will act as a distributed service. And then you don't know anything about Napster, Grokster, and those sort of old file sharing applications we used to use years ago before other services came along. It's based on the fact that we've got this distributed service of different providers where we're sharing that peer-based or that file-based transfer. Obviously, we talked about port 80 or HTTP and HTML. HTTP is the transport, HTML is the markup and the content. And actually HTTP can be used to transport many other things as well. URL, Uniform Resource Locator, will say the protocol, then the domain, and then the file or service. Okay, and the colon // Tim Berners-Lee admits that's a bit redundant. He could have just had the colon, but yeah, those were the days. And the forward slash shows it's actually a file naming system. So if you'd had / Cisco / Meraki / wireless / index.html, then you can see it's actually subfolders. In the file system, and index.html is often not shown up. It is actually default index.html or HTM, and some servers even use default.html as well. But that way it will just go out, the browser will do a HTTP GET and ask the server for a page, and then it will actually receive the HTML code sort of received downstream. So there's HTTP get, puts, and posts on a sort of web request, and it's get, send up, or upload different data. So post is to send form data, that which is in the field, and a put is to actually upload file service. And you can actually use get some puts to actually do some inappropriate discovery on web servers as well. And obviously that's tools that can be used by hackers where they will probe your web server and see what else is in the folder. So sometimes people leave sensitive data and other resources, and they're trawling using broken link services and HTTP gets and puts. Email, well, there is IMAP, SMTP, POP. So basically, POP and IMAP are used to receive, and SMTP, Simple Mail Transfer Protocol, is used to send mail. There's two separate ports, two separate channels, which means that they can act as a full duplex service. So it can all be happening at the same time rather than one way. And we have it sort of running on port 25, and it's port 119 for POP, as I may recall. Oh no, 110. Oh, it's 119. Anyway, I'm gibbering a little bit, but 110 will receive the traffic accordingly, and then IMAP will be used to retrieve mail where it will allow the server will allow the client to keep copies accordingly. Obviously, you have DNS services where DNS we map domains to a IP address for a web server or service or any other server. But on DNS there is an A record, there's NS quad A's and MX records. A record says that I now got an authoritative address, a domain that maps to this IP address, and the name server has the authority to say what can and can't do that, and obviously a quad A will do exactly the same. And an MX is now a mail exchanger record, and some services also use text records or TXT to point to specific sub-services, so that you can point to a sub-page within the system as if it's a top-level domain, which is often used by many hosting websites. Here you can actually use a sort of different range of message formats where it will ask questions and answers, look for authority or resource additional records accordingly. And there is a DNS hierarchy. People don't realise it's from the right to the left, so .com or .co.uk, it's actually .uk, then .co, then it's .whatever, and then www is a subdomain. So actually open.ac.uk. .uk is run by obviously Nominet.ac is run by JISC. Open is our own organisation's authority, and then www is a subdomain. So I could have, though I don't, cisco.open.ac.uk if I was allowed to offer that. I am not, but there is that level of depth, and you can actually keep going down and down and down. It's up to you how you would manage those subdomains which point at specific services or sites within your infrastructure. And by using NSLOOKUP, or you could use ping, you can actually discover information about the domain and the service. In fact, there's actually a lot of online web services as well. DHCP, Dynamic Host Configuration Protocol, automatically allocates IP addresses to devices. So rather than fixing a static address to a device, you have a dynamic address. So if I'm going to go into a cafe with my smart device and connect using the Wi-Fi, it will allocate me a temporary leased IP address, which hopefully we will do shortly. And that way it uses something called a discovery, offer, request, and then acknowledgement process, and that's why it works on UDP. So it's going out and discovering if there's a DHCP server there. And then if it isn't successful, it'll get a PIPA or 169 address, which some of us have encountered. Do this practical lab. It will help you explore a little bit of DNS resolution going on a network. Obviously, there are different file sharing services. FTP has been around for a long time. Obviously, there is now secure FTP, and you basically use two ports. One is for the commands, the control commands, and the other, port 20, is for the data to be transferred, where we pull and push. And you have discovered that HTTP and FTP do work in synchronicity with each other, where there are certain services that take place that you can actually FTP down a download or download a file using HTTP. And you also encounter SMB service message block, which has a more permanent connection. There's also other services as well that do very similar, but that is more of a permanent connection within a secure network infrastructure. Okay, I've whistled through this because I'm more interested in actually setting up this network. So I've set up this network, and I've got this PC that's got a 10.00.100. I've got a web server here with 10.00.10, got a DNS server with 10.0.0.1, and I've got a DHCP server with 10.0.0.99. And if you look at all of them, they've all pointed to the DNS server. They've got 10.0.0.1. But at the moment, what I'm interested in doing is I'm just going to go to the web server, and I'm actually going to set up the services. I can see the web server's on. I can see there's an index.html, and I am going to edit this. Just basically very simple bit of editing where I just go into, I try not to delete out all the wrong commands, but I'm just going to do a simple, welcome, mind wide open. So hello from the OU. Okay, nothing clever there, so I've just got a simple horizontal row, and I'm actually going to put in a line break as well. Okay, so nothing clever there. Save it. Okay, overwrite the file. Then if I go to the PC and use the web browser, wait for it, Andrew. There you go, and do 10.0.0.10. You can see Cisco Packet Tracer, hello from the OU. Okay, not rocket science, but it's just gone out and it's done an ARP actually, and it's then gone to the 10.0.0.10 and said, like, can I have a HTTP GET, and then I've grabbed the traffic. And you can see it's not actually asking DNS for any information, but now if I go into the DNS server, and I'm going to go into the config here, services, then go to DNS and switch it on. I'm going to just do an open.uni domain, and it's going to have an address of 10.0.0.10 because that's the IP address of the actual web server. So remember, the DNS server has 10.0.0.1, the web server has 10.0.0.10, and each of these devices points to the DNS server for a DNS lookup. So I've switched the server on, and I've done that. So I've got that 10.0.0.1 that was working quite comfortably. Sorry, 10.0.0.10. But now if I do open.uni, and I've made up this top level domain because it's my own internal network, and you can see it's worked quite comfortably. But if I just type in a V and click on go, it's hostname unresolved because it doesn't know about it, because that's an incorrect entry. Okay. And then if I go to the DHCP server, and I'm going to set up the DHCP server now. So I'm going to go to the servers, and I'm just going to do a DHCP, and it says, you can see it's a start address 10.0. Look, it's picked up its local address, subnet man. So it's all set up, and I'm going to switch the service on. But I am going to say that, the DNS server has got to be set up, so 10.0.0.1, because otherwise it won't connect. And I am actually going to save that, so you can see the change there. It's got no, but I'm going to set the start IP address to be 123 there, and save that. And I'm doing that because it's quite obvious, because we've got an unsubnetted Class A, note the air quotes, private IP address. I've actually set it up in that, but I want it to be quite clear so it can actually talk. Not worried about a default gateway on this network, but now I'm going to go to the PC, which is statically IP address, and I'm going to go to the IP configuration and now give it DHCP. And here you go, 10.0.123.0, but it's connected with no issues whatsoever. And then if I actually run the web browser now and just do the open.uni, it's all connected, and it's actually run that quite comfortably with no issues. Now obviously we would like to see this all happen again, so I'm just going to quickly save. And I am going to quickly add another device on our network, and it's often hidden, but we have the packet or protocol sniffer. And I am actually going to move this cable. Sometimes it's difficult to move the cable, you've got to be a bit fiddly with it. So Ethernet 0 there, and I'm just going to throw a straight cable in here and just put that back into port 1. And then I am going to save again. Okay, intentionally, so all the configs are there, and then I am going to restart all devices. So there is no configurations on the switch, and I've saved everything else. I hope it may go wrong. I'm going to fast forward it and fast forward it again. Okay, so if I hover over it, you can see it's got its IP address. You can see that the IP address is set up correctly there. I'm just going to check that that's still the way it was, which is fine. I'm just going to check the DNS server entries are correct. Yep, that is all fine. And then I'm just going to see that the DHCP server, well, we can see that it worked, but I'm going to double check. So that is all fine as well. So what I'm going to do now is actually open up the sniffer and open up the GUI. You can see already there's been some ARPs. You can see the DHCP has taken place. You can see that it's sent out the initial request. So the conversation has been quite busy as it was talking and replying, and you can see the client address, and then eventually you should be able to see the new addresses being given out accordingly. There you go, address issued. Request, response. Okay, and obviously there are some ARPs taking place as well as it's trying to find out who is where and what is what. But now if I actually bring this up, and I'll just bring this here, I go to the web browser and do the open.uni, two things will happen. Look, DNS. It's immediately done a DNS, then it's done a TCP, then it's done a HTTP. So it had to do a DNS to do that lookup, to find that information, find out the authoritative information that was taking place. And then it also did an ARP to find out where the actual server is. So you go .10 that we're going to talk to here. And there is a HTTP GET being sent as well. Here you go. So it's all quite a communicative system. So it's actually pulling the data, and we saw that take place quite quickly. So the nice thing about this practical demonstration I've done, you could have this all on one server. I deliberately built 3 servers to do this quite quickly. You can obviously have email services, DNS services, DHCP services, web services, and other services running on your packet tracer network quite comfortably. And by throwing in a sniffer, you can see what is happening on the network quite simply and quite clearly. And I am actually going to save this and make sure that you are able to download this as well. Thank you. I've been Andrew Smith from the Open University, and hopefully you found this useful as part of your Cisco studies.